Spiders glide, curves obey. Design.
Hi, welcome to Parametric House. In this tutorial, I want to show you how you can make this parametric surface using a Kangaroo plugin with a series of goals. Let's turn off the algorithm and explain the step by step. So first of all, we have two curves as the starting point. You can give any closed curves. This is the bottom and this is the top. To go forward, I've used the surface freeform ruled surface. If I turn this on, you can see that this is going to create a ruled surface. Okay, now that we define the number of divisions that we want, which is going to give you more details if you increase the UV division, what you have to do is to define a Kangaroo goal. So I'm going to use the Kangaroo main. You can use different solvers, but I'm going to use the bouncy solver here, as you can see here, which is going to give you an output. We have to define the goals. I've merged all of the goals using a set tree merge. And if you zoom in, you can see that you can give different inputs to the merge. And that is a good way of organizing them. So when we give it to the goal object, it's going to be one output. Okay. The first thing I always use in the Kangaroo plugin is the Kangaroo main show. So as you can see here, I've used a mesh to show. That is the first goal. The good thing about this is that when you give it to the goal object, the first output is going to be the output you want. So as you can see, it's invalid here because we have too much pressure. But anyway, we can pick that up with a list item and use that as an output. So let me put this pressure to 0 and reset the simulation. Here you can see that we will have the mesh and we can pick it up with this list item. I'm going to turn that off. If I reset the simulation, you can see the output here. If you want the damping to be a smaller number, you can say, for example, 0.2 to 0.99. And that is going to give you slow animation. The number of iterations by default is 10. I'm going to give it a bigger number. So for example, 40, it's going to make it even faster with a smaller damping. Okay, so you can just play around with these numbers. You can also give a toggle, TOG, Boolean toggle to the on, and that is going to, we want to run the simulation. So if it's false, it's not. If it's true, it's going to run. Okay. A good thing about this is that if you put it to false, it's going to pause the simulation. And sometimes you can even use that to pick up a part for it. For example, I'm going to run this and pause it, for example, for this part. Okay. So you can do that whenever you want to get an output. Okay, the next goal we want to define is the goals mesh, and it's going to be a load, for example, vertex loads, and that is you can just give the mesh to the input, and as you can see here, I've connected that to the mesh just while display that hidden because I wanted to clean the algorithm. And if I give this a minus number, for example, 0.1 minus, it means that it has actually it's a weight downwards. It's like minus g. Okay, so as you can see here, it's downwards. If I increase that, that's going to go more down. If I give it a plus positive number, it's going to go up. Okay, so you can just always play with that number. That is another goal we have defined. Another thing we have to define is that this is a tensile somehow structure. So I'm going to use the goals mesh edge length, which is going to convert each of the edges of a mesh into a spring-like structure. Okay, so I'm going to give the mesh to the input. The length factor, you can put that to 0. It's going to actually try to make it smaller as possible. 0 is going to mean that it's going to can reach a 0 length. For example, these can come into a 0 point, but it's going to break the mesh. So this is just like maximum flexibility. If you increase it to 1, it's going to mean that it can't deform, and as you can see here, it's a little bit awkward as an output. So I'm going to give that also as the third goal. Okay, the next goal we want to use the Kangaroo plugin is the goals point anchor, and we want to fix these anchors on the ground. So as you can see here, these points from the top and bottom has to be selected and they're not going to move. Okay, to get those points, you can go to mesh and get the naked vertices of the mesh. It's going to give you naked points. As you can see here, because the surface is a little bit based on the ruled surface, it has a naked edge here, okay? So we have to get rid of that extra points we have here. What I've done here is that I said, okay, curve analyzes, and I think that curve CP here we have to use, curve closest points. We say, okay, which one of those points are closest to these two curves we have from the top and bottom. I've graphed this. If you don't know about flatten or graph, you have to watch the data management sections from the Paracourse beginners. We have talked about that. And what we have to do here is actually say, put them into two outputs. As you can see here, it's, for example, this point is going to be projected on the curve at the top, and it has a distance here. And it's also going to be projected towards the down here, okay? We don't really care about this because we can say, okay, those points that are projected on these curves and the distance is near zero, we want those. And if it's not zero, obviously we don't need that. So you just have to say, okay, the distance is it smaller than some small number or something like that? And then we can use the set list dispatch to dispatch them into groups of true falses, which is going to be the top and the bottom. And we're going to use that as an output. So that is actually the points we want to fix. We can go to the Kangaroo plugin and say goals point anchor and anchor them on the ground and give that to the D4. Okay, the next thing we want to do here is actually the next goal is the pressure. So goals mesh pressure, as you can see here. We want to define a pressure. And as I increase this pressure, it's going to inflate it. If you give it inverts, a minus number, it's going to go inverts. But remember that this number has to be really small, especially based on your project. I think that the safe number is going to be from 0 to somehow the maximum 0.1. But be careful about this number. Don't increase it too much because it's going to break the mesh. So just put that into a small number and get the results. Another thing we have added in this example is the goals mesh wind. So I've just added a wind to the mesh here. Because the direction of the wind, I wanted to define that. I've made a point here. As you can see here, when I change the point, it's going to change. And as you can see here, we can go from negative to positive, the direction here. And what I have done here is used a point as the point attractor somehow for the direction of the wind. Then I've used the surface area of the bottom circle, bottom curve, which is going to give you the centroid for that. And then I said, okay, the direction is going to be somehow in this direction. So to make that vector 2 point from this point to this point, and this is going to be the V. Because I wanted to make this controllable, I've used the vector unit vector to convert that into a unit vector and then multiply that with a number here. And then just give that to the W. Also for the visualization, I again made a unit vector and used display. And we will have a vector display here from the point we have here, and with a multiplication of the V like 50 times just for more visualization. One of the things I want to explain in this tutorial is that when I change the inputs, I want to reset that automatically. So you can use this Python script. It's just like a simple script here by Andres DeLorean, and you can use that in Python. And then when you actually use this code, you just have to give a new value to it, any values you have from your algorithm, and a button for a reset, and then give that to the reset simulation. So what I want to explain here is how this is going to help you to reset everything automatically. So for example, as you can see here, I have added different values. One is from the length, I've connected a number to the curves at the top of the bottom here. So that is going to give you the length of the curves you have. Another thing I have added here is the UV count. So as we change the number of UV count, that's also going to affect the results. Another thing here is that the length. I've converted the point attractor into a number. So actually that's not really important what the number is, but when you change the location of the point attractor, it's going to automatically change the number. So it's going to reset the simulation. So I've added all of these to this number flattened. So as you can see here, we are getting some information from our algorithm, which is changing. So after that, what we have to do here is to go to the math and add them up, mass addition. So as you can see here, let me explain this. What it does, it's going to add all of these numbers up and give you this number. And when you have this number, it's actually going to change each time these values change. Obviously, this number is going to change, and that is going to trigger this Python script, and it's going to give you a new output. So that is also really useful if you want to have an output. Also, this button is going to reset the simulation, is somehow something like that. If you connect that here, if I connect to here, and let's change this. For example, I'm changing the UV. As you can see here, it's going to be true and then jump to false. It's going to rerun the simulation. So it's going to be really great. Maybe we just want something like that. And that is how it's going to reset the simulation. Whenever you, for example, change the location of this curve, it's going to update also. Okay. So I'm going to internalize that so you can use it in your project. And I think that's all about the simulation. You can get the outputs as a list item. I've also connected a mesh edge to see the mesh edges here. And a custom preview just for a custom preview of the mesh and also mesh edges. That's all we want. So as you can see here, we can rerun the simulation and change things easily. Change. And that's it. I hope that this tutorial was useful. If you have any question, ask below. See you next time. Bye. Remember that you can download these example files all from our website, parametrichouse.com. And remember to subscribe to our channel, like this video, share it with your friends, and let me know in the comments if any additional examples you need so we can record the tutorial. Thanks for watching. See you next time. Bye.